You've probably seen it happen countless times. Dark clouds rolling in, the sky flashing bright for a split second, followed by a deep rumble that seems to shake the air itself. Lightning first, then thunder. It feels almost dramatic, like the sky is reacting to something powerful. But what's actually happening up there? It looks simple, but it's driven by powerful forces high in the atmosphere. What causes thunder and lightning in the first place? Let's dive right into it, right here on History of Simple Things. To understand it, we need to start inside a cloud. Not just any cloud, but a towering thundercloud called a cumulonimbus cloud. These clouds can rise more than 12 kilometers into the atmosphere, taller than Mount Everest is high. Inside them, air currents rush up and down at incredible speeds, smashing water droplets, ice crystals, and hailstones together in a chaotic, stormy collision. This constant collision is what creates electrical charges. As ice particles bump into each other, they transfer electrons, tiny negatively charged particles. Lighter particles become positively charged and rise to the top of the cloud, while heavier ones become negatively charged and sink to the bottom. Over time, this builds a massive electrical imbalance inside the cloud, like a giant invisible battery charging in the sky. Now, here's where lightning is born. When the electrical charge difference becomes too great, whether inside a cloud, between clouds, or between the cloud and the ground, the atmosphere suddenly breaks down. Air, which normally acts as an insulator, breaks down and becomes ionized, allowing electricity to rush through as lightning. That flash we see is actually a superheated channel of air. Lightning heats the surrounding air to around 30,000 degrees Celsius. That's about 5 times hotter than the surface of the sun. This extreme heat causes the air to expand explosively, faster than the speed of sound. That rapid expansion creates a shock wave, and that shock wave is what we hear as thunder. But here's something interesting. Lightning and thunder actually happen at the same time, but we see them differently because light travels much faster than sound. Light travels at about 300,000 kilometers per s, while sound moves at only about 343 m per s in air. That's why you see the flash instantly, while thunder takes seconds or even minutes to reach your ears depending on how far away the strike is. If you've ever counted the seconds between a flash and a rumble, you can estimate how far away the storm is. Every 5 seconds roughly equals about 1 kilometer of distance. So if you count 10 seconds, the lightning struck about 2 kilometers away. It's a simple but powerful way our senses help us measure something happening high above us. Lightning itself comes in different types, and not all of it hits the ground. The most common is intra-cloud lightning, which happens entirely within a single cloud and is often responsible for the flickering flashes you see lighting up the sky. Cloud-to-cloud lightning jumps between clouds. The most dangerous is cloud-to-ground lightning, where electricity strikes Earth. Cloud-to-ground strike is the lightning most people imagine, a jagged bolt splitting the sky. But it doesn't travel in a straight line dot. It zigzags in stepped leaders toward the ground, then connects with a rising charge, triggering a return stroke, the flash we see. For thousands of years, people saw lightning as divine power, from Zeus's bolts to Thor's hammer. Even today, lightning still holds some mystery. Scientists continue to study rare forms like sprites and blue jets, massive electrical discharges that occur high above thunderstorms, reaching into the upper atmosphere. These events were only confirmed in recent decades because they happen so quickly and so high up that they're difficult to observe from the ground. Thunder, on the other hand, is often misunderstood as something separate from lightning, but it's really just the sound of the same event. That explosive heating and expansion of air creates sound waves that bounce, echo, and rumble through the atmosphere. Thunder rumbles as sound from different parts of a lightning channel reaches your ears at different times. Interestingly, the shape of the terrain can also affect how thunder sounds. Mountains, buildings, and even clouds can reflect and distort the sound waves, making thunder echo or stretch longer than expected. So in some places it sounds like a sharp crack, while in others it rolls on as a deep, rumbling echo across the landscape. This variation depends on how far the sound travels and how many surfaces it bounces off before reaching your ears. Lightning is not just a spectacle, it's also incredibly powerful and dangerous. A single bolt can carry up to 1 billion volts of electricity. It can strike the same place more than once, especially tall structures like skyscrapers or radio towers. The Empire State Building is struck by lightning dozens of times a year. Nature doesn't care about landmarks, it follows the easiest path. Despite its danger, lightning also plays a surprisingly important role in maintaining Earth's natural balance. Each strike helps convert nitrogen in the atmosphere into compounds that plants can absorb, effectively acting as a natural fertilizer during storms. This process enriches the soil, supporting plant growth and ecosystems, showing that lightning isn't just destructive, but also part of Earth's life cycle. So the next time you see a storm brewing, remember what's really happening above you. Inside those towering clouds, tiny particles are colliding, separating charges, building up invisible tension until the sky itself can't hold it anymore. Then, in an instant, that tension releases as a brilliant flash of lightning and a deep, rolling thunder that reminds us just how powerful our atmosphere really is. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.